Right, what one do you need to say?
There's only like one small step. I always go
Okay. Which one? Which one? Show me. What type is that? Oh yeah, I can show you that. It didn't work out?
No.
Maybe you should type on that. I'll check it out. 4D.
Yeah.
Yeah, I'll check it. But it's possible the answer might be wrong, so let's see. And then which one, Sarah, did you want? Sarah? Okay. So the first thing I'll do, Fumi and Fian, I'll just check that the answer is right using Derive, okay? So I'll just type in B. You still have Derive installed on your computer? Yeah, so you can still use it. No, but this is to check if the answer is right at the back. Okay, so integrating this. 3x. Which one did I do? B, wasn't it? I think the sign might be different here, but is that what you got? You got plus or minus in B? Alright, well we check D then. So D is 16, 96 and 48. 16, 96, 48. Oh yes, that's, no, 148. It looks like I just have the sign the wrong way around, but the numbers are all right. 2x and a 6 and a 2. Yeah, I have the wrong sign though, but the numbers are right. Is your question about the numbers or the sign? Oh, so you want to see it then? All right. I need to check the sign. All right, so I'll just hold this here for a second. So I'll tell you what I'll do. I will do, what one did you say, Sarah? C, was it 2C? Okay, I'll do 2C and 4B as an example, yeah. Okay, so 2C, integrate 7x plus 5 over 7x minus 2. Okay, so full screen that. U equals 7x plus, minus 2. Du dx equals 7. So therefore, du over 7 equals dx. And also here, this can be rewritten to say x equals u plus 2 over 7. Okay, so going back to the question, this now becomes on the top, whoops, x plus 5 over u du over 7. Now the reason I left it like this is to point out that the x here is a problem. We have u's. Well, we just replace the x with the formula we have for x, which is u plus 2 over 7 plus 5 over u. You can put the 7 out in the front, and then you have your du there. Now what happens to the 7's here? They cancel. So you get now 1 over 7 integral u plus 7 over u du, which equals 1 over 7 integral 1 plus 7 over u du, which will equal 1 over 7 u plus 1 over 7 times 7 is cancelled, and antiderivative of 1 over u is log u plus c. So the answer is 1 1 over 7, 7x minus 2 plus log 7x minus 2 plus c. There's the answer. So your step you're missing, Sarah, is the replacement of x. That's all. Okay. Now, I will do, I guess D is a tiny bit more difficult, so I'll do 4D next. So, scroll down. 4D. Integrate 16 all over 16 x squared plus 96x plus 148 dx. Now, the problem here is you don't want the 16 here. So if you take out your calculator and divide everything by 16, so 16 divided by 16 is 1. 16 divided by 16 is 1. 96 divided by 16, does that even go?
Yeah.
What is it? 6. And then 148 divided by 16? 37 over 2 dx. Now, what we do next, I'll scroll back up, don't worry. What do we do next? We complete the square, yes? 32 over 4. Sorry, 37 over 4, yeah. So what we do is we complete the square. X plus 3 squared. Now, I need somebody to type in on their calculator here 37 over 4 minus 9. Exactly 1 over 4? Okay, so now we have this. Now, who remembers the trick for the substitution here? You say u equals, the trick is square root x plus 3 squared over 1 over 4, which will equal 2x plus 3, which is 2x plus 6. So what does du dx equal? 2. So what does dx equal? d over 2. What is x plus 3 here? Well, actually, I think what I'll do is I'll leave it with the 2 on the outside instead of multiplying it in. Because if I look at this, what does x plus 3 equal? U over 2. Can you see that? X plus 3 is u over 2. So what do I put here? U over 2 squared plus a quarter equals a half du over u squared over 4 plus 1 over 4. Now, how can I get rid of these quarters? What would I multiply the top and bottom by to get rid of the 4s? Well, I'll just multiply the top and the bottom by 4. So this would be 4 divided by 2, of course, is 2. And then the 4's go here, and you're left with this. This has a special formula. What is it? Yeah, tan inverse u. And u here is 2 times x plus 3. Or 2x plus 6. So yeah, I think the sign is backwards here. I think I have 2x minus 6. Yeah. Scroll up. How far? Here? The beginning? No, 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 no. You'll have to catch the video, I'm sorry. This is your one. No, is that any clear? Why do you want me to send us this? Why do you send it to me at the start? Not loud enough. Speak up, please. If you wanted it, you should have said something clearer. What's the difference with B anyways? Show me B. How is B different to this? But how is question B different to this one? Well, I don't understand what the question is, though. But at least we're a fraction, right? Which is exactly what happened here. I got a quarter at the end. It's identical to that. The numbers are just different. No, no, no. You're smart enough to get it from this example here, I think. I have complete and utter faith in you. I can't say that about many people here. Right, Brendan? Right, next topic now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Apart from Joseph, are we missing anyone else? Oh yeah, I felt like there's kind of another talky person missing as well. Avenue. Mohammed's right there. Look at him. Right there. Yep, there's Mohammed there. Okay, next topic now. Okay. Hey, look. Look up. So if you want to add these together, you know the quick way to do it? Remember, we multiplied the denominators. Yes? You get x squared plus 5x plus 6. And then we do a cross here. So that would be 2x plus 4, and then we do a cross here, plus x plus 3. So in total, what do I get on the top? 3x plus 7 over x squared plus 5x plus 6. And the question now is, are you on your phone, Faisal? No, don't move. Don't. Yeah, okay.
Is that an 8 or
I can make it like torture. I can put the clamp around the screen, and then I can just, every time I look down and I'm not happy with what I see, I just make it a little tighter. You know? What? It won't feel, it'll feel no pain? Alright. Now, if you look here, at the end I have a linear over quadratic. But at the start, I've got a constant over a linear and a constant over a linear. So, which do you think is easier to deal with, the first or the last here? Which? The first, but why the first? There's no squares in it, you know. You saw how to integrate this. What would you do to integrate the 2 over x plus 3? What do you do? Let u equal x plus 3. Although if you try to let u equal to x squared plus 5x plus 6 here, it wouldn't simplify. And if you try to complete the square and let u equal to the root of the first over the second, it also wouldn't simplify. So what we're going to learn today is how to go backwards. How to go from the end back to the start. Okay, so how to go from linear over quadratic back to the start. So firstly, some vocabulary. You don't have to write that down. That's just my example here. If you have a polynomial over a polynomial. Who remembers the name of this? What's it called? What type of function? We did it like literally in the last class, and it's possibly the name on the last worksheet as well. Where's it going? What's it called? Rational function. In today's lesson, for us, the power on the top will always be smaller than the power on the bottom. So for us today, we'll only look at those types. So for example, it could be linear over what, quadratic, or linear over cubic, or quadratic over cubic, but not quadratic over linear, and not cubic over linear or quadratic, and not linear over linear, or quadratic over quadratic, or cubic over cubic. The power on the top will have to be at least one smaller than at the bottom. Okay? Right, so let's look at the first type to deal with then. So write this one down. So for example, minus 12 over 3x squared plus 8x plus 4. Now, somebody give me a Casio calculator. 991. Yes. I don't think it's the wrong way, but I think I can do this quicker myself. So we want to solve this quadratic first. We want to factorize it. So I get here minus 12 over 3x plus 2, and then x plus 2. Firstly. Now that's great, because when it's written like this, it actually is kind of clear what the two denominators should be. If you flick back for a moment, how did I get this quadratic here? What did I do? I multiplied these two denominators. So by writing the quadratic like this, it becomes clear what the two denominators should be. So we have minus 12 over 3x plus 2 times x plus 2. That should equal, I'll make a lot of space here, some number we don't know over 3x plus 2 plus some other number we don't know over x plus 2. So our task now is to find out what the a and the b is. Okay? So we have to simplify this. Any ideas on what I could do to simplify this?
You can make 1 equals to 0. Sorry, find a value that will make 1 equals to 0.
Oh, you're jumping too far ahead. No, before that. And anyways, I don't like that method. I won't do it that way. So what can I do here first? I could, if I wanted to get rid of these denominators, what would I multiply by? I should multiply by both of them, shouldn't I? So the first, that cancels that cancels that. And then I put the 2 here as well. And then the first one cancels that. And then here, the second one cancels that. I'm not writing them in because it's 3x plus 2 and x plus 2. Here, 3x plus 2 and x plus 2. And here, 3x plus 2, x plus 2. You can write them in if you want. Anyways, after you multiply, you're left with this. Now I open up the brackets. Right, that's an equals there, of course. And I group terms together. Yes.
And how about in the start, like where A is, right? What if you make x equals minus 2, and it cancels A out, so you have B left, and you can get what B is.
I told you I don't like this method. I don't like it. I will show you it later in the class, but not right now. Yes, this is not a method your teacher likes. I'm so sorry to tell you this, so sorry, but I don't like this method. Yes? Yes, okay. Now, if you look here on the left, you got minus 12 plus, how many x's on the left? 0x. And if you look at the right, you get 2a plus 2b plus a plus 3b equals x. So now, in order to find the a and the b, you have to make a comparison between the left and the right hand side. So, who thinks they can tell me what I can say from this line here? What do you think I could say if I'm comparing left and right? I have 2a plus 2b. What should that equal? Minus 12. And then what about a plus 3b?
0.
So it equals 0. Now, why is that? Or is that your question? Yeah.
Did you move the x to the other side?
No, what I'm doing is, if you look here, on the right I have a number plus a number times x. And on the left I have a number plus a number
Where did you
times
put
x.
0 times
Ah, there's no x here, so I wrote in 0x. Because there's no x there, there's no 0 x's. So I compared, this number must be the same as this number, and this one here must be the same as that. It's a lot like, if you think back to semester 1, I'll just write it here, but you don't have to write this down. Remember when we said y equals mx plus c, and then if I said y equals 2x plus 3, what's the slope here? What's the m? 2, and what's the c? 3. So you got that by comparing this with this, because you can say this equals this because they're both equal to y. You see? So m equals 2 and c equals 3. I don't know how people feel about that.
Why didn't you put just x so it would be 1x?
Because there is no x. There's 0 x's. There are no x's on the left.
Oh, okay.
Yes. Proceed. Now, what can I do to simplify this here? Yeah, divide by, firstly divide by 2. Okay. Right, 2, 3, 2b, b equals 3, and a equals minus 9. Yeah. Huh? Isn't b not equal to 3? I just solved this, the elimination method in my head. Right? Is that right? I am going to take it for granted that solving a simultaneous equation does not need to be demonstrated at this stage in your life.
Yes, you meant
No, I think that is perfectly reasonable. At this stage in your life, solving 2 equations, I should not have to show you how to do that. Right? The silence I'm not liking. I prefer lots of nodding. Like, yeah, simultaneous equations, got that down. I'm not getting that. No. Okay. That's just finished now. That's the A and the B found for this. So I can go back to the top, and I have the A and the B now. So what was, I'll have to write it out again. It equals minus 9 over, what was the first one here? 3x plus 2. Plus 3 over x plus 2. I can go on. I'm seeing more people not writing than writing, so I'm going to go on. Next example. Minus 22x plus 62 all over 45x squared minus 19x minus 42. That equals minus 22x plus 62 all over 5x minus 6 and then 9x plus 7. And now we know that this should equal a over 5x minus 6 plus b over 9x plus 7. And we are looking again for the a and the b. So what can I do to simplify? I multiply everything by these. So when I multiply everything by that, I'll be left with minus 22x plus 62 equals a times 9x plus 7 plus b times 5x minus 6. So I get here 62 minus 22x equals 9ax plus 7a plus 5bx minus 6b. So I get 66 minus 22x equals 9a plus 5bx minus 6b minus 7a. Oh, I wrote that backwards. Well, it doesn't. Yeah.
62.
No. And yes, that's a 62. It changed. 62. I'm putting the constant first in the front. So the constants are 7a minus 6b minus 9a minus 5b x. And the reason I wrote it like this is to make it look identical. On the left, you have a 66 or 62, and on the right, you have a 7a minus 6b. And then on the left, you have a minus sign, and on the right, you have a minus sign. And then on the left, you've got a 22, and then on the right, you've got this. And then on the left, you've got an x at the end, and then at the right, you've got an x at the end. Yeah. So the yellow pieces are the same, the blue pieces are the same, the red pieces are the same, and the grey piece is the same. So what can I say 62 equals? 7a minus 6b. And what can I say 22 equals? Minus 9a minus 5b.
Minus 22x.
What?
What do you do with the x?
I'm not, well, I can say x equals x. But that's not good. No, because I'm looking at the number, not the sign, because I have the signs already the same. Now, I want to solve this. So I get here A equals 2, B equals minus 8. Huh? I solved using the elimination method. How many methods do you have to solve simultaneous equation? First method, substitution, another method, elimination, another method, graph, another method, matrix. So now that you have the A and the B, you could go back here and now you got the answer. This equals, what was the A? 2. 2 over 5x minus 6 plus, whoops, minus 8 over 9x plus 7. I will do another example and I will show you the method Sadiq was talking about. It is quicker, but I don't like it. And somebody at the end will tell me why I don't like it after you see it. So next one now. Example. Minus 6x plus 22 all over x squared minus 10x plus 25. Minus 6x plus 22 all over, and here is the problem. When you factor this, you get x minus 5 times x minus 5. Now this is a big problem actually, because don't write down the blue part. You cannot say it's equal to this. You might think, it's x minus 5, x minus 5, so I'll just write it twice, right? But in fact you can't, because if you add these together, it will not make the original. It won't. So, what do you do? This is our problem. What do you do when the factors repeat themselves? How do you deal with that? So what you do when the factors repeat themselves is the following. You take one of them, keep it the same, but then for the other one, nope, you take the square of it. So when factors repeat, you go, like for example, if this was like x plus 1 squared, you'd use x plus 1 and then use x plus 1 squared. So when factors repeat, you use the original and just one of the factors. You always do that when it repeats, when you have this situation. Now, some people might be thinking, but that's not right, because if I multiply a linear by a quadratic, what do I get? A cubic. And what do I need? A quadratic. But think for a moment. Now listen, look up, listen. Think for a moment. This denominator is almost like this denominator, agreed? So what would you multiply the top and bottom by to make the denominators the same? You could multiply the top and bottom here by x minus 5, because what would you get at the bottom? X minus 5 squared, and on the top, x minus 5 times a. So then the denominators are the same, so when two denominators are the same, they just go together as one. Like 5 over 6 plus 1 over 6 The 6's just go together as one single 6. So then we do have a quadratic in the denominator. And then a times x minus 5, what type is that? Linear or quadratic? It's linear, isn't it? And a linear plus a constant is still linear. So in fact, this does indeed make linear over quadratic of the form here. So let's go ahead. Like before, what do we multiply everything by? The x minus 5 squared. So now you get minus 6x plus 22 equals a times x minus 5 plus b. Now we'll use the method Sadiq was referring to earlier. So when you look at this equation, what I normally do is I multiply out the right hand side and make comparisons, as in the last two examples. Whereas another method would be you recognize that the left hand side must always equal the right hand side for any value of x. So for example, if I choose x to equal 5, what do I get on the left? Minus 30 plus 22, isn't it? Minus 30 plus 22, minus 8. And what happens here? 0. Yes? Right? And then what am I left with here on the right? B. If I choose x equals 5, this will be minus 8, and this here on the right will just be b. So look, you have b. You see? What you do is you choose a number that cancels, so you can have just one piece left. Some people are accepting this, some are not accepting this. Here, let me go back here. Let's go back to this one here. What would I have to choose x to be here to, for example, and let me go even further back. Yeah, let's go all the way back to here. What would I have to choose x to be here to cancel this? Minus 2. Yes? Look up, look up, look up. X has to be minus 2. That will cancel this. What's 3 times minus 2? Minus 6. Plus 2? Minus 4. So you have minus 4b equals minus 12. So what would b equal? Yes? So you see, it's a lot quicker to do. So who can tell me why their teacher not like this?
Because I have the denominators my cos. Like they repeat the same. And
No. You're going on the right track. Some other idea? No. The reason is, for me to do this, I have to choose x equals 5, right? But can I choose x equals 5 in the original?
no.
So I'm deliberately choosing something I should not really be choosing. Although it works for a bad reason. Most of you won't care. All of you won't care. But I prefer the other way. Anyways, now that we have the b, we can find the a. If I plug this back in, I got minus 6x plus 22 equals a times x minus 5 minus 8. Now, what's the easy number to choose for x now? Yeah, well, like, just make x equal to 0, maybe? So what do I get on the left? 22, and then on the right, I got minus 5a minus 8. So if I take that over there, I get a equals minus 6. Okay. I see students outside. No, they can wait a minute. All right, I think I'll split this lesson into two because I've just done linear over quadratic, but now we also have to look at quadratic over cubic and also linear over cubic. So I'll tell you what, I'll give you the questions and I'll tell you which ones you can try that you should be able to do.